Hello, I'm Michele from messautomation.com, and today we talk about Sharp7, that is a library to communicate with Siemens S7 PLC by using C#. So let's see how we can download the library. So you can go on messautomation.com. There's an article how to write a Siemens S7 PLC Sharp7. Here you have the links to download the library. I already downloaded it, but I can show you. So you go on SourceForge, then you go on Sharp7. Then you go on downloads. Here you find Sharp7, and the most recent version is daily, and you just have to download sharp7.cs, that is basically the sources of the library. So here we downloaded the library. If you need the entire package, you can go on Sharp7 full, you download it, and with this download you will download a full zip package. It contains Sharp7 folder with the source, that it's not the last version, it's the first version. So the bugs here are not fixed. Here you have examples for Windows Form, Console and Universal Windows Platform. And also you have documentation and the user manual. So this is all you have to do to download the Sharp7 library. So if we take a look at the user manual, there are several sections that are interesting. For example, you can see the compatibility of the functions of the protocol in the page 9 of the user manual, where there is compatibility. Here you can see, for example, that the CPU 300 and 400, they are compatible with all the instructions, but the CPU 1200 and 1500 are compatible only with reading of output, input, markers, and dB. Also, CPU logo and S7 they are compatible again only with dB, input, output, and marker reading. So basically, if you need to read the timers and counters and set PLC date and time and so on, you cannot do that on the newest CPU. So to connect to the PLC, you need to specify 3 parameters. One is the IP address, the second one is the rack, and the third one is the slot. Now we are going to create a project in C# to connect to a PLC. I will use PLC Sim because I actually don't have a CPU, but it's basically the same thing to connect to the PLC Sim and to connect to a real PLC. This is the portal V13 Service Pack 1. So if you download the project and you can just open the project from the portal, and so you have to unzip the project and open the project. Okay, in this project I have a bunch of DB and program blocks. A really simple project just to show some features. For example, I have a timer and a contact and a coil, and then I have 2 DB with some variables of different types, so I can show you also some conversions and how to read from a DB1 and a DB3. To connect with Sharp7, we have to set the protection of the PLC on the device configuration. So we double click on device configuration, we go on the user manual, and as you can see under protection sections, you see that you have to set protection on the CPU on full access. So on device configuration, you click on the CPU, you go on the bottom, you click on protection, and then you click on full access. And here you have to click on permit with put get communication on blah blah blah. I already did this before. Also, to read the DB, there are other instructions in the user manual. So you go on DB property, you have to uncheck optimized block access. So for example, you go on properties on the DB1, and on attributes, this must be unchecked. This is checked by default. You have to remember for every DB to uncheck this. Once you uncheck this, you see that you have the offset of the value. This is what we need to reference the memory. So let's create a C# project right now. So I will start with a new project. And name it Sharp7 example. So simple console application, nothing too difficult, just to connect and to read and to write some DB. Before starting, we have to include the Sharp7 library. Usually I create a second project to include the library. I will just right click on the solution, add new project, select class library and write Sharp7. So, and on Sharp7 I go on my downloads, I will grab the sharp7.cs file, I will put it on Sharp7 project, build the project. Okay, then I go on my project. This I don't care anymore. We can also delete this class. This is my project. I will add a reference to Sharp7. So I changed the name of Sharp7 in Sharp7 library to don't have the same name for the class and the project. Okay, let's go to our program. The first thing that we do is using Sharp7. Then we create a client. This is not needed. Then we have to connect to the PLC. We use the method connect to. This will ask us for address, rack and slot. We will find rack and slot in the portal. We have to go to device configuration. Here we have to click properties. Then go on the top to general and here we find rack and slot. So slot is 1, rack is 0. These numbers must be exact if you want to be connected. Then we have to check for the connection result. Then we have to disconnect at the end. Let's check that these values are correct and that the connection works. Perfect. Okay, yeah, there is a small error. Okay, now we can go on the portal and read the DB1. To read DB1, we can read it in one read, we can read all the values in bytes. So we have to read 34 bytes plus this value that is 4 bytes. So we have to read 38 bytes. So we have to use a method read db read. Okay, this will ask the db numbers. It is db1 from starting from 0, the size is 38, we said, and it asks us for a buffer. A buffer is an array of bytes. We can create it. Perfect. So we can give the length of the buffer and the buffer itself. This gives us a result. So we can check the read result. Good. Let's see if this works. Okay, here we're reading. Read result is 0. So our buffer should contain the data. Here are the data. Okay, these are a bunch of bytes. We need to convert them. So to convert them, we have to use the Sharp7 functions. Okay, let's see the data. So we have two bits at address 0.0, 0.1. Let's read them. 1. Then we have to read for an integer. Okay, again. Okay, this number is just the offset. So to convert this variable, if I'm starting from 0, I have to write 2. So then we have a real, then we have a int, then we have a word and the word. Okay, let's check for now these values that they are correct. We don't have to check for correction in conversion because there are no communication, so we don't have to check for results. So the first is false, second is false, 50, 36.5, and 1, 2, 3, 4, 5, 6. So they seems to be corrected. So let's see how we can read the hexadecimal values. So, but okay, with unsigned integer and unsigned short, we are not going to read the hexadecimal value, but we are going to read the numeric value. So let's just run it, and this is what we obtain. So let's read what we have here. So the first one is 1E240, and this is 1E240. And the second one is E240. This is wrong. Yeah, we are reading the wrong address. So, sorry. Here we go. 3039. This is how to read a full DB and how to convert the values. So you have to create a buffer of all the bytes that you want to read, and then you have to specify the position of the words and convert. So what we do now is to write some values to the DB. We will start to write some values to db1.dbw2, that is the integer at offset 2. So to write the value is really similar to read the value. But this time, instead of reading a buffer, you have to write the buffer. So in this case, we have to create a buffer of 2 bytes because you are writing an S7 integer, so they are 2 bytes, 16 bits. So let's create the buffer. Now we have to fill the buffer with the data that we want to write. So we will use setInt, so s7.setInt at, and then we ask for the buffer, write buffer, and we can set the position, so the position is 0, and we can write 15. So now we can write on the DB. We have to check for the right result, and again we have to check if it's correct or not. So let's put a breakpoint here. Here we have 50 on DB2. So now we are going to write 15. So our right result is okay. And we should see 15, and so the right is correct. So we saw how to write a single value to a DB. Now let's write multiple values on the DB. We are going to write from offset 0 to offset 12 excluded. So we will write all these 5 variables. So we need 12 bytes of different types. So we need booleans, a real and a double integer. Okay, let's see how we can do that. This for booleans we need set bit at. This sets the first bit to true. This is wrong because it needs a reference, so we need to prefix this with ref. So let's add the second bit, and we just have to change the index. For the integer, now we are writing from 0, so we have to change the index, the position, and put it on 2, that is the offset of integer starting from 0. So we have the real, and we can use set real at 22.2. It needs a float, so we have to prefix it with f. The last one is a dint, and so we can use s7.setDint at. Okay, we can place again a breakpoint here and check that everything works. The byte is too little, the array is too little, so we have to make it 12 to make it work. So now that we have no errors, and the write has happened, and as we see we set this to true, then 20 and 22.2. So it's really simple to write consecutive values in a DB. Just create a buffer, and you just need to set the correct position and index, and you are done. So an interesting feature of Sharp7 is also the possibility of reading and writing multiple variables. By multiple variables I mean multiple DB in the same read. So this has several benefits like a faster communication and less TCP requests being exchanged between the TCP and the C# program. So to read multiple variables, we can use the function S7 multivar. Basically, it's like reading a single variable, but you have to create multiple buffers. So in this example, we will read both the db1 and the db3. On db1, we are going to read the 34 bits, and the db3, we are going to read the first 18 bits. So as said before, we are going to create two buffers, one for db1 and one for db3. So we create a buffer of 34 bytes and 18 bytes. Then we have to create a multivar variable, and we have to pass the client. So after creating an instance of S7 multivar, we have to add the two buffers to the class. So we are going to use the method add, and there are several overloads. We have to select the one that has 5 members, so we can specify the area and the length, db number, and so on. So we use s7 consts.db, and here it's .byte for word length. Then we specify the db number, the start, the buffer length, and we give a reference to the buffer. We are going to do the same for the db3 buffer, just we have to specify db3. So again, we are going to read the db in bytes. This time we read the db3 from 0, again db3 buffer.length, and ref db3 buffer, and here it was db1 buffer. Okay, so now we can read, so we can just call s7 multivar.read, and the Sharp7 library will read in one call both db1 and db3. This returns an integer, so again result, and we have to check if it's correct or not. Sorry. Okay, we can execute the method. Here we execute the read, so it is completed, and as we see, db3 will contain the buffer from db3, and db1 reads from db1. Again, we can convert all the data. I expect that they are the same for db1. For example, we can convert for db3 just to see if they are correct. So let's just change and let's see. So false, false, minus 50, minus 25, minus 1, 2, 3, 4, 5, 6. So again, I put all the values negative, and it's working. So like before, to write multiple areas, I have to create multiple buffers to set the values into the buffers, and then I can write them by using S7 multivar. So let's see how we can do that. So let's just write some values. We can, for example, write this minus 50 and this minus 25, and we can write in db1 the 50, that is now it's 20. We can create a buffer. Okay, because we have to write only an integer, I will create a buffer of only 2 bytes, and then we create a buffer for db3 of 6 bytes. So we set the first buffer value, we set int at position 0 value, we can just use minus 50, and then we can use set s7.set int in db3 buffer. Let's put +50, and we can set a real, and it needs a float. Okay, so same as before, we create a multivar class, a multivar instance. Now we have to add the buffers. So now we have to add the value, but we can reuse the code before, but we have to set a different start index this time. So here I have a start index because I'm starting from index 2 here and 2 here. So because we start now from this variable in db1 and this variable in db3, we have to specify the start because our buffer is only 6 bytes. So here we have to change the index. Good. Then we can use the same code to write, but instead of it, let's just change and use write. Then we can check the result, and let's see what happens in the debugger. So it wrote, so let's go see what happened. On db1 we wrote -15, and on db3 we wrote wrong values. So let's see what happened and why we wrote wrong values. Let's go back to the code and let's check. But for db1 it was correct. For db3 we can see we set the buffer. The first is 0 and the second is 2. So we committed an error on setting the index. This is something that happens frequently, so you should be careful by setting the index correctly, see, both here and here. Now let's run again. Let's see if this time we wrote them correctly. So as you see, 50 and 55.55 and -50. So basically this is Sharp7. In the same way that I read the area, the DB area, I can read a lot of other area. Just as you see, we can read counters, markers, input and output, and timers. Again, on the latest CPU, you can just read and write DB area and input and output, because the timer and the counter are implemented as DB variables. Okay, this library has a real good documentation, and all the methods that we used in this example are explained very well in the documentation and in the examples. So you can check the documentation, for example, for the conversions so there are all the error codes, there are all the methods used on the last part of the user manual with all the examples. So you can't go wrong with this library. Also, Dave Nardella is very fast on bug fixing, and on SourceForge there is a forum you can report there the bugs that you find. Okay, if you want to download this example or a similar one, you can again go on my website and you find the link on the GitHub example. So in the bottom of the article you find the link and you find the example to download. And here you have all the code or similar code that we used in the sample application. So if you like the video, subscribe to the channel. There will be more on HMI and more on drivers for PLC and C# development. And like the video if you like it, and leave comments and everything, and see you at the next video.